compute this line integral where f is given by this vector and c is any path from 1, 2, 2, 3, 5. Let's see if this force field is conservative. First, the domain of this function is all the points in the plane, all the xy values. That means the domain is simply connected. Okay, the domain of f is all numbers in R2. That means simply connected. Next, we say the first component is P and second component is Q. And we find the parcel of P with respect to Y and parcel of Q with respect to X. If they are same, then this vector f is conservative. Okay, so let's find parcel with respect to y. X cubed parcel with respect to y 0 minus x is constant, parcel of y is 1, so x times 1, so just negative x. Parcel of q with respect to x, so negative 1/2 constant times derivative of x squared is 2x plus derivative of 2y with respect to x is 0 and negative 1/2 times 2 cancel, so just negative x. They are same. And since the domain of this vector is simply connected, all points, there is no hole, we know that f is conservative. What does that mean? That means conservative means there we can find a potential function. We can find a function f such that when we find the parcel of f with respect to x, we get p, and parcel of f with respect to y is q, such that parcel of f with respect to x is p, which is x cubed minus xy, equation 1, and parcel of f with respect to y is second q, negative half x squared plus 2y. All that means the gradient of this f is f. Okay, now we would like to determine this little f, which is a potential function. For let's integrate 1 with respect to x. Equivalently, we can integrate 2 with respect to y. So when we integrate the left hand side, it's just f as a function of x and y equals integrate with respect to x. So this is x 4 over 4 minus y is constant and antiderivative of x is x squared over 2 plus constant. But this constant could be a function of y because we are integrating with respect to x, and function of y could be a constant, so hy. This could be a pure constant, just like 5, 7, 9, or it could be a function of y. Equation 3. We are almost there. We almost found f, but we need to determine h. To determine h, let's find the parcel of f with respect to y so that we can compare with equation 2. Okay, so differentiate 3 with respect to y. Okay, that's f y. This is pure function of x, so 0 minus this is constant and derivative of y is 1, so this x squared over 2 times 1 plus this is a single variable function, so partial derivative is same as regular derivative h prime y. Okay, now compare 2 and 4. Okay, let's compare then what are you gonna get now? Left hand side parcel of f with respect to y, negative 1/2 x squared here, so h prime y is just 2y. Integrate both sides with respect to y, so h of y is y squared plus some constant. Since we are looking for a potential function, we may take c equals 0. Okay, it's arbitrary constant but just 0. So h of y is just y squared. Now come back 3 here, plug in h of y is y squared, then we have a potential function. Thus f as a function of xy is x⁴/4 minus this is 1/2 x squared y plus h of y is now y squared. Okay, so we got a potential function, and now we can evaluate this line integral using the fundamental theorem of line integrals. And we have any path 1, 2, that's the initial point, let's say a kind of, and this is b. So this line integral, now the line integral of dot dr is same as, because we have little f whose gradient is f, this is same as f at terminal point minus f little f at initial point, which is f what is the terminal and initial points? 3, 5, 1, 2. 3, 5, 1, 2. Evaluate this function we just found here, this function at 3, 5 minus evaluate at 1, 2 and write down the number. That's the answer. Just plug in 3, 5 here and 1, 2 and do the math, arithmetic, we get 39/2 final.